Mr. Beacon podcast is sponsored by Wiliot, scaling IoT with battery-free Bluetooth.
Welcome to the Mr. Beacon podcast. This week we're going to be talking about how to be successful in asset tracking and how to be successful as a CTO. Now, I'm talking to a CTO now, Jim Stratigos, who is CTO at Cognosos. So Jim, thanks very much for joining us on the show.
Steve, thanks for having me.
You have a job that many people aspire to, especially on the technical side, but really being a CTO is quite a complicated job. And you've been a CEO, you have worked at Cisco and Motorola and AT&T. You've had a great background to learn on. So once we've finished our drill down into what your company does and how you're carving out your niche in asset tracking, I want to get some career advice from you for anyone that wants to be a CTO, and we'll cover that. But first of all, tell us a bit about what your company does. At a high level, what's the kind of the elevator pitch?
So we provide an asset tracking service platform using some patented technology we developed in conjunction with Georgia Tech in the area of low power wide area networking. So we have our own LPWA technology, and now we've combined that with our own location technology to allow us to do more and better.
So asset tracking and inventory, what typically are the things that you're tracking?
So our largest customer segment today is automotive. So we're tracking about 80,000 vehicles at dealers, auctions, and automaker plants to give the owners and operators of those lots visibility as to where the vehicles are, where they've been, how long they've been there, kind of all the logistics information you would want in an ideal world about what is very valuable inventory before it's been sold. So at an auto manufacturer, these are vehicles that are sitting on the lot before they're transported to dealers. And of course, at dealers, they're waiting for a customer to buy them. And then once you've driven your car for a few years and turn it back in, it usually goes to an auto auction, and the same kind of process occurs there. So we give those customers the visibility in as to where their inventory is.
And you've got some good names on your website. You're in Atlanta, so that's home of Cox Automotive. Are they one of your customers?
Yes, they are a customer as well as an investor. And we also have some large automotive customers. Hyundai Glovis is one of our customers. They're the logistics arm of the Hyundai and Kia, the automakers. And we're serving their plants in Georgia and Alabama with our service. And then a lot of the companies that are in the independent auction world, companies like Dealers Auto Auctions up in Spokane, Washington, they're one of the largest independent auto dealers in the country with probably 5,000 or 6,000 vehicles in inventory. So it's pretty much across the board in the auto industry of anybody that needs to know where their cars are, not while they're driving down the highway, but while they're sitting in the big parking lots.
Yeah, it seems to be, it's a high value item, and so I can see why tracking those assets would be important. But why create your own LPWAN technology? Are we short of LPWAN technologies, or?
Well, good question. We got our start, before Sigfox and before LoRa, so we're, probably within a year or so of all three companies coming out with their respective technologies. And we have a lot different spin on it, I guess, if you say, but we're based upon software-defined radio technology. And what that does is gives us all the cost advantages and range advantages of any LPWA technology, but we're not locked into any particular silicon. So we can use silicon radio devices from, as any number of dozens of companies around the world, and go where we get the most cost-effective solution for a particular use case. So in a lot of our products, we use the same chips that are used in your key fob. And so instead of being limited to, say, a range of a few tens of meters, we get a few kilometers out of the same chip, just with a different modulation scheme, and using software-defined radio in the cloud to sort out the good signals from the bad signals and make the link better.
Okay, so you're getting great range. You don't have to pay royalties to Semtech, who create LoRa, and you get to use commodity chips, but you get that additional range. And why do you need the longer range? Because Bluetooth has pretty good range, doesn't it?
It does, especially Bluetooth LE and the Bluetooth 5.1 long range profile. But we do even better. So we get several kilometers of range, and it's a simple equation of cost of the infrastructure. So one of our gateways with a radius of several kilometers can cover very large outdoor areas. For example, at one of the large automakers, their plant's over 600 acres, and we cover that entire facility with 3 gateways with a high degree of redundancy. So to be true, probably 1 gateway would cover it, but we put up 3 just to give overlapping coverage areas, make sure there are no dead zones, and to handle the capacity of the vehicles at that lot. They have over 20,000 cars, so you got to have a lot of network capacity to handle all the information that the tags are transmitting.
Wow, that's amazing, 20,000. So how do you squeeze? So this is a commodity chip. How can you get that range for someone that's not kind of familiar with different modulation techniques? What are the trade-offs if you want to get that extra range? I'm assuming that it's not a free ride.
There's laws of physics which we'd all like to violate if you're on the Starship Enterprise we could, right? But so the laws of physics pretty much dictate that the range of a wireless network is inversely proportional to the data rate, right? We found that out in the Bluetooth world. Mm-hmm. So we use very low data rate transmissions, generally below 1 kilobit per second. And that's okay because the amount of information that are being sent in these networks is quite small. A few hundred bytes a day of location information or status or temperature, the typical kind of IoT use case. And then the other way we get greater range is we eliminate largely this effect that's called multipath, where in the real world, obstructions in pavement and buildings cause multiple copies of a wireless signal to arrive at the receiver. And by using the software-defined radio technology and our cloud signal processing, we can kind of sort out the good signals from the bad signals and increase the range by doing that. So the kind of a combination of using low data rates, we have a very advanced forward error correction code, and using the cloud signal processing to eliminate the multipath noise.
Fascinating. So you've used this term software-defined radios a few times. Can you explain what that means?
Well, instead of using silicon like you're in Bluetooth and Wi-Fi and LTE, where there's silicon on each end of the link, right? The silicon in our laptops and our phones, and there's silicon in the access points that implement a particular protocol like Bluetooth. We implement our protocol in silicon in the tags, but in the gateways we use just a general purpose computer and essentially a fast A to D converter to sample the spectrum, and then we use software to implement the protocol, to implement the physical modulation and coding and packetization is all done in software. So it provides a great deal of flexibility rather than being forced to say, look at that signal in real time as you would in a chip and decide whether the packet was good or not. We can take our time, and we can also throw additional processing power by using the cloud to sort the signals from the noise and thus improve the range. So it's quite a clever technique, and it's quite flexible technology. Also, from a frequency standpoint, by changing a few parameters in the gateway code, we can operate at 400 megahertz or 900 megahertz or even at 2.4 gigahertz.
And what affects your decision about why would you want to have that flexibility? Why change to these different frequencies?
Well, in an ideal world, what the RF engineer would like to do is have a completely clean slate when they design a network. So if you give them a scenario, let's say, monitoring location information from thousands of vehicles spread over, a few kilometers, they would, start with a blank slate, look at the frequencies that were available, and pick the most fitting frequency for the application. And if you do that, you generally will pick frequencies below the typical license-free bands at 900 megahertz and 2.4 gigahertz, because lower frequency signals are able to penetrate buildings better. They don't reflect as strongly from objects, so you get greater range simply by operating at lower frequencies. So that's the reason we picked, for example, 400 megahertz for outdoor applications, but use 900 megahertz and 2.4 gigahertz for indoor applications.
Okay, makes sense. And tell us a bit about the use cases. Why are these car dealerships trying to implementing your systems? Is it simply a lot of cars, 20,000 cars, difficult to keep track of them? What are the business drivers, and where's the ROI for all of this?
So yeah, it's a good question. It comes in two forms. One is cost savings. So in order to dispatch a driver to retrieve a vehicle for sale or transport, for example, or to send it to the auctioneer with a gavel who auctions it at an auto auction, someone has to go find the car and drive it. And before we came along, the incumbent technology was barcodes, and the lot personnel would scan every car on the lot, maybe more than once a day, but at least once a day, and then record its location either as GPS coordinates or as just row A, spot 4 on a map. And by putting the tracking device in the car, you no longer have to do that. So it saves time. It saves the labor cost of the personnel who are doing the scanning. It makes retrieving cars faster, so you can be more responsive to your customer. And then you get faster inventory turns, because if ultimately your job is to get those cars off the lot, right? They need to be sold or they need to be shipped to a dealer if you're an automaker. And the more rapidly you can locate the cars for transport, the less time they spend on the lot, and the greater the ROI.
So I can see how your long range would definitely allow you to cast a broad net and see where that a car is there. But don't you lose something in terms of the locality? It's like, if I have a very short range, then I have to have a lot of infrastructure, but I can get a pretty granular view of where things are. Is that a trade-off that's real, or is just knowing that it's on the lot good enough?
No, we actually use GPS technology outdoors, usually within 2 or 3 meters. So it's an interesting question because it gets into the whole beacon area as well. So, when do you use beacons for location? When do you use other technologies? And what we found is we had to use a combination of both. So, GPS works great when the car is outside, but what happens when it goes in a building, which
Yes.
they often do?
Yes.
GPS is pretty useless under a metal roof. So then we use beacons to give us an approximate location of the vehicle. We know what door it went in or what door it went out of because we can detect the proximity of a beacon.
Okay, so what are you actually putting in the car then? It's what do the tags look like that that you are creating? Aha.
So I brought some show and tell. So this is a typical automotive tracker. I think you can see it on the camera.
Yeah.
This particular model is designed to clip to the visor of a car.
Yes.
So you just like a garage door opener.
Yeah.
And it's quite simple, really. It uses a motion detector to detect when the car is moving. Mm-hmm. It has a GPS chip to pick up the GPS satellites, and then a UHF transmitter chip to transmit that information back into the cloud when the car ceases motion. So its life is spent. Most of his life is spent asleep mm-hmm. until it's called on to do something by the motion of the vehicle.
And how long will the battery in that last?
So depending on the number and the type of batteries, anywhere from 1 to 4 years, depending upon the particular use case, and also dependent upon the number of times a day the car moves.
And obviously they get recycled and used on multiple cars. And roughly what's the ballpark in terms of the cost?
So we're kind of unusual in the asset tracking business. We don't sell anything. So we actually provide all the hardware, all the infrastructure, and all the applications as a SaaS business model for a subscription fee of a few dollars per month per vehicle. The more vehicles you have, the lower it is, and the fewer, the higher it is, as it would be any case with a SaaS business model. So it's kind of an interesting value proposition for us as a company and for our investors, and obviously it it gives an impetus for the engineering team to always looking at ways to reduce the cost of this device, because obviously that improves our bottom line and our customers' bottom line. Yeah, I'll show you the other side of the product line. That's a beacon-based tracking device. I'll turn it right side up, and you can see that on the website. But this is designed for tracking in a hospital. So it can't use GPS, so it actually uses beacon localization.
Okay, and so you're doing trilateration to do that, or just RSSI, or?
It's actually an RSSI-based technique that uses the fingerprint of the space to locate the beacon. Or locate the tag. The tag listens for beacons, and we use beacons as our indoor GPS, if you will.
Okay, and so are you using your gateways with that?
Yes.
Okay.
Same
so
gateway technology, just at a different frequency, and they're put in wiring closets instead of outdoors on light poles.
And what are the assets that typically people are looking to track?
So this goes back to the old RTLS definition. That acronym came out of healthcare in the early days of RTLS in hospitals. So that's the market that we're addressing with this particular product is healthcare. But the same core technology, maybe with a different form factor and perhaps a different battery, could be used to locate pallets in a warehouse or anything that's valuable and moves and need to be located. Right.
All right. And are you using the same SaaS model as with the cars?
Yes, we are.
All right. Presumably slightly lower cost, or?
Yes. Yeah. Obviously, smaller form factor. It doesn't use GPS, so it's a little bit less expensive to manufacture. But I think it's a real need within multiple industries these days to locate things indoors. And beacons are great for proximity localization. If you walk by something with a beacon on it, you know it immediately with a smartphone. But if you don't have a smartphone, you need other ways of using beacons to locate objects in X, Y, and Z.
So SaaS it's the fashionable thing. If you want a good valuation, then you have a SaaS business model. So have you always done it that way, or was there a transition to that?
No, we started out that way. I'm as you know, an electrical engineer and been through many startups, and every startup made something that was hard, right? that you had to go sell. And as you know, when you either make chips or make devices that have chips in them, you're always looking at your gross margin and what the price points are and the competitors' price points, and then you sell the product, and then you kind of you sit back and say, oh, I'm done. That customer is happy, and we can go on to the next thing. So I guess because we'd done that before, and because some of my partners are very experienced SaaS software leaders, we decided to give it a try, even though there's hardware in our product, obviously, to develop a pure SaaS business model from day one.
And how did the company get founded? What's the founding story?
So I guess I was the first guy to wake up and say, I think this technology that we had worked on at Georgia Tech was interesting, and we filed some patents, and darn if the patents didn't get issued. And so I looked at where I was, and I was actually retired at the time, and what I could do with the technology, and I thought it would be worthwhile to pursue commercial interest for the technology. So I ran into some friends of mine who said, Jim, what do you think goes in the hallway? Next thing I know, they said, well, we could do this and go after this business and this application, and we started a company based upon those early conversations.
So I have to apologize to the listeners and viewers. The connection's a little choppy. We've been struggling a bit, but I wanted to have the conversation. So I hope everyone bears with us. Wiliot's about to move to new offices, and so I'm optimistic that we've got a super fast connection and we'll have less choppy conversations. But I think we got the gist of what you were saying there, Jim. Maybe we can digress into this whole CTO thing. I've often, as a manager, and sometimes I've managed business people, sometimes technical people, and often when I speak to the technical people, the question is, well, what do you want to do eventually in your career? And quite often they want to be a CTO, and so I'm interested in your story about, is it really as good a job as it's cracked up to be? Is it should people be aspiring to be CTO?
Yeah, obviously depends on your personal situation and where you are in your career. I'm a little unusual in that I'm an old CTO. I didn't actually have that title until I was in my 60s. So I've had all the other titles pretty much, and I'd have to say, just in perspective, I like this one the best.
Okay.
It's partly because my name was on the original patents. It was kind of natural for me to assume that role.
Mm-hmm.
And the more we grew the company and had customers and investors, the more I liked the role entails, which is providing the strategic direction of the company's technology, especially around intellectual property. I spent a lot of the early days of the company, obviously working on the patents and making sure that our IP was well protected, and then look at product architectures, not just for next year, but the year after. So yeah, it's a fun gig, and I envy the younger guys that just go and get involved with startups and take on the role of CTO at a young age. I think it's good to have worn different hats, and the CTO role can be quite fulfilling.
And I see CTOs kind of in two varieties. One is where they're kind of the intellectual leader, the one driving IP and architecture, and one where they're doing that, and they're very kind of engineering development focused. Are you responsible for the development of the product?
So yeah, I kind of wear both hats. I've got a real senior engineering team. We assemble the company from folks that have worked together over the years in multiple startups. So, unlike most of the Silicon Valley startups, our average age is probably entering the gray hair level. So a lot of guys with 10, 20 years experience. So fortunately, there's a lot of strength in the team to manage the day-to-day stuff. But yeah, I get to be involved. We're only 20 employees, so we're still a small company. I get to wear both hats. Some days I do strategy, and some days I dive into the firmware or hardware issues involving the product releases and future product development.
And what advice would you give to someone who's an aspiring CTO in terms of the skill set that they acquire? I have often looked at this role as needing business acumen as well as technology skills, because you've got to hold your own in the executive team, and frequently you're involved in helping to engage new partners and customers, and articulating and forming a technology roadmap that's not just driven by what's cool and what will work well, but what's actually going to allow the company to be successful. Can you maybe either contradict, amplify, give your take on this balance between the different skills required to be a CTO?
Well, yes, you're absolutely right. Certainly in a company that is dependent upon hardware technology as part of our platform, you better be familiar with spreadsheets and ROI and being able to contribute to formulating the company's business models based upon the technology roadmap that you lay out, right? It can't be done independent of cost. And I think that's the challenging and exciting aspect of the job. Is it's fun to always be challenged to drive down the cost of functionality in wireless technology. I know you guys are familiar with that at Wiliot. So yeah, it strains the brain cells when your CEO or CFO says, that widget that we buy for $10 today, when do you think it'll be $1?
Yeah.
I like that challenge. How much time do we have and how much money you're willing to spend to lower the cost by a factor of 10? That's a great challenge that engineers love to dive into. So yeah, I think the business side of being a CTO is essential. I don't think you can kind of jump into it right out of engineering school, for example. Having been involved with selling a product and making a business case, so developing a business plan for a product, I think that kind of goes with the territory.
Interesting. And then what about that other dynamic, which is you're a leader? How hands-on should you be if you're the CTO?
Yeah, I'm a bad case of that because I'm an inveterate tinkerer and maker. Didn't know what the term was when I was, a young engineer, but now I'm an older engineer. I love the whole maker and hacker movement. So I sometimes need to be dragged off the bench to do other things. Given left to my own devices, I'll be out there with a soldering iron and a spectrum analyzer and making measurements or coming up with new modulation techniques or exercising new test equipment. That's another thing that us older engineers like to do is go out and acquire some fancy new pieces of equipment and show the young guys how wonderful it is and how you're supporting their engineering efforts.
Excellent. Very good. Well, that's fascinating. Thanks very much, Jim. I enjoyed hearing a bit about what you guys are doing at Cognosos, and hopefully I think I've learned a bit through our conversation about LPWAN and software-defined radios, and the business model is really cool that you guys are executing too. And thanks for your perspective on the career thing as well and how to be a CTO. So appreciate your time.
Yes, Steve. No, thanks for having me as a guest. And I'd encourage listeners obviously to check out our website. And we have new products that, of course, Bluetooth based for indoor locations. So I'd encourage all your listeners to check that out. And obviously, if anybody has any questions, feel free to reach out.
Thanks a lot. Have you been able to give some thought to the 3 tracks that you might take on a trip to Mars, Jim?
Yes, it's really limiting. I was thinking 3 albums maybe, but when you try to distill it down to 3 tracks, it really forces you to think. And so I kind of went through my iTunes library and looked at the songs that I play routinely and tried to pick different genres. So I picked 3 songs and we'll see how they go. So the first one is Miles Davis, All Blues, from the Kind of Blue album. I'm sure you probably have heard the song. It's just a great song. Plus, it's over 11 minutes. So for those long Mars nights, at least it'd give you some extra listening time.
That is a great album. That's a great album.
Yeah,
I love
of course,
the
you got to
choice.
have something for the Beatles. It's hard to pick one, but I guess if I had to pick one, it'd be Yesterday.
Yes.
And then something a little more modern, but not too modern in terms of rock and roll. So there's a local band here in the States, in Georgia, you probably never heard of, called the B-52s.
Oh, I actually have heard of them, as you might have guessed, and I've seen them as well. They were in San Diego last year.
Oh, really?
So, yeah.
Yeah, so they have a kind of apocryphal song, Rock Lobster, which anytime I turn on the radio, my wife and I both, start the toe tapping, and it's really just a great, fast moving song, gets the blood going.
Fantastic. And going back to the Beatles and Yesterday, does it evoke a time in your life, or is there, obviously, who can argue with the Beatles, but is there something personal about the Beatles that resonates with you?
It was a period, right? So I grew up in the 60s and the Beatles were on the radio. And I remember, being when the first time they appeared on the Ed Sullivan Show. And I was, probably 10 or 11 years old. And I got out a little cheap reel-to-reel tape recorder and set it on the TV set and hung the microphone in front of the speakers so I could record their appearance on the Ed Sullivan Show. And I remember my grandmother being in the room and, shaking her head like an older person back then would have done. What are these long-haired kids thinking about? It's awful. And I remember saying, Grandma, they'll be famous one day. And I wish I still had that tape, but it's long gone.
Fantastic. And that's probably the best thing she could have said to pique your interest anyway. Very good.
Yeah, exactly.
Very good. Well, thanks very much for that.